Gravitational potential energy. Gravitational potential energy is how much energy something stores up based on how high it is. Gravitational kinetic energy is the energy that something has as it's actually falling through the air. Total gravitational energy looks at these two things put together. In this picture, the pie graph shows the kinetic energy is the blue and the potential energy is the pink. The entire pie, all as one thing, would be the total gravitational energy. Gravitational potential energy can be affected by two things: mass, how much stuff there is, and height, how far away something is from the ground. Let's start with a skateboarder that has a small mass. Look how low the total energy, potential energy, and kinetic energy are on the graph over on the left. Also notice that the kinetic and potential energy never go higher than the total energy. Now let's look at a skateboarder with a large mass. The lines over on the left in the graph are much larger. We have more total energy. We also have more potential and kinetic gravitational energy. When something has more mass, it also has more gravitational potential energy. When something has less mass, it has lower gravitational potential energy. I'm going to take the mass of both of my balls. My cork ball has a mass of 4.75 grams. My metal ball, on the other hand, has so much mass that my scale can't even measure it. I'm going to drop the ball with the most mass onto clay. We can see that it left a large dent in the clay that's almost as big as my finger. Now I'm going to drop the ball that had the lower mass. Look, it just bounced off the clay. The clay doesn't even have a dent. That's because this ball has much less gravitational potential energy when I hold it above my desk. Another thing that affects gravitational potential energy is how high up something is. The higher up it is, the more gravitational potential energy it will have. Something that is low down and close to the ground or to the table will have less gravitational potential energy. Watch what happens as I move the skater up and down the skate track. If I do it before I start, I'm deciding how much energy will be in this once I press play. The higher up the skater is, the more energy it starts out with, and the higher total energy is. Notice that when the skater is at the very top ends, the potential energy is at its highest. Gravitational potential energy is highest when the skater is furthest away from the ground. If I start the skater lower on the track, the skater has less gravitational potential energy when it starts. This means that the skater won't go as high up on the other side of the track. When the skater is high, we have high gravitational potential energy. The top is where this energy is the highest. When the skater is at the bottom of the track, it has the lowest gravitational potential energy. Another thing that you can notice is that kinetic and potential energy do the opposite of each other. When potential energy is all the way up, kinetic energy is all the way down. Balls on ramps will work the same way. They have the most gravitational potential energy at the top of the ramp and the least gravitational potential energy at the bottom. The dots are closer together at the top because the ball is moving more slowly. This is because it has low kinetic energy and high potential energy. As the ball gains kinetic energy sliding down the ramp, it gets faster and faster. This makes the red dots space farther apart. So we can see that the kinetic energy is highest at the very bottom of the ramp.